Hey, the second side of our sheet on working with squares, excuse me, is we're gonna draw some squares off the side of these triangles, and these are special triangles, and it's my mistake not to put a little right corner in each of our triangles because we're talking specifically about right-angled triangles. Now I went ahead and I drew some squares, but I'm going to ask you guys to just kind of sketch some squares that fit on each side of our triangle. So I want us to draw a square off of each side of the triangle. And if you look at the blue square is going to be 3 centimeters by 3 centimeters. The purple square is going to be 4 centimeters by 4 centimeters. And the orange square is going to be 5 centimeters by 5 centimeters. So we're drawing squares off of each side of our triangle. And the next thing we want to do is we want to find the area for each of our squares. So the area of this square is 5 squared. So this area is 25. The area of the big square is 25, 5 by 5. If we go to the area of the purple square, this area is 4 squared. I don't know, I've been writing brackets and everything, but 4 squared. So this area is 16. And the last one we want to look at is we want to look at the blue square. And this blue square is 3 squared. So this blue square has an area of 9. So the thing that's most important to us here with right-angled triangles is how the areas go together. We have an area of 16, an area of 9, and an area of 25. And what's neat about this is, and this is only true when you have these special right-angled triangles, is if you take the area of the 2 little squares and add those 2 areas together, it'll always equal the area of the big one. So the 9 plus 16 equals 25. So it's the area of the squares that we want to add them to get 9 plus 16 equals 25. And this is Pythagoras' theorem. If you think back to what you did before, you had a squared plus b squared equals c squared. The a squared is the area of the little triangle. The b squared is the area of the middle-sized triangle, and the c squared is the area of the big triangle. So the 2 little triangles always add to equal the big triangle. So that's what we want to talk about. The next thing we want to look at is another triangle, a 5, a 12, and a 13 triangle. So let's just take a second, and again, I know I've got my squares, I pre-drew them, so they're sitting here, and I'm just going to be able to drag them out. So take a second and draw your own squares. We're going to draw a square that is a 5 by 5 square. We're going to draw a 12 by 12 square, and we are going to draw a 13 by 13 square. So again, I pre-drew my squares. You're just going to have to freehand sketch your squares on your triangle. But hopefully I set it up so that you have room to draw those there. We've got a little overlap, but that's okay. So the top square, its area is 5 squared, so that area is 25. The purple one, this is a 12 by 12 square. So 12 by 12 square, we got to figure out how many squares are inside this one. That's a lot. And so if you had 12 rows and 12 columns, you don't want to be counting all those squares in there. That's where on your calculator you can use the squared button, or you can just go 12 times 12. And 12 times 12 is 144. And then we have the orange square this time. And again, this is 13 by 13. So this area is 13 squared. Again, if you want to find the squared button on your calculator, you can go 13 and then squared, or you go 13 times 13. And 13 times 13 is 169. So again, if we go with the idea of Pythagoras, our math buddy, a squared plus b squared equals c squared, the little area plus the medium area equals the big area. So what we're talking about, the little area was 25. The medium area was 144, and the big area is 169. That information or that pattern only works when you're talking about triangles that have a right angle in them. So again, that's my mistake. When we started this question, we should have had a right angle in the corner, because this only works for right angled triangles. It doesn't work if you don't have a 90-degree angle in there. So now we want to be able to use this information to help us find missing sides of triangles. Our first page is about just knowing how squares and square roots work. Our second page here was about, again, reviewing Pythagoras, where you have the small squares add up to equal the area of the big square. So now we're going to try and combine those two thoughts into another assignment.